Okay, next is the dot product. So dot product is important for the work term specifically because we have, gonna write the equation next to it. We have the work equation to be f dot d. So between the vectors, when you do a multiplication, you have to show that dot. So if you're multiplying 2 and 3, you don't really say 2 dot 3, right? Because there's only one form of multiplication between numbers or scalars, but between vectors, this is a dot product. Later we will add cross product. So you have to show which one it is. So notations are, again, very important. That dot has to be shown. And so what we're saying is, if you want to do this algebra, vector algebra, we need to understand how to deal with it. And there are two ways that you can calculate the dot product. So the first way, I use it. So instead of using W, I'm using just A dot B. Okay, it's just vector A and vector B. The first one, I use it if I know the vectors. Let's say this is vector A and this is vector B. Okay, I'm given what the magnitude of A is and B is and maybe theta. These are what I have. Then I'm gonna use this form. A dot B, again, they are bolded. I just wanna emphasize and show that these are vectors, just like F dot D I show. And the magnitude of A times magnitude of B. Again, I do not need to show that dot anymore because these are scalars. I'm multiplying them. And the cosine of the angle between them. Okay, in my example, theta is probably 90 degrees, right? They look perpendicular to each other. So if it is 90, cosine 90 becomes 1, then A dot B becomes simply A times B. And whatever the magnitudes are, you just multiply them to find out. Okay, so this is one way of writing it. And the second way, I use it if my vectors are given in vector notation, like a unit vector notation. So maybe A is given as AX I had plus AY J had, and I'm just assuming two-dimensional case. This is BX I had plus BY J had, okay? Then I'm gonna use this, and I'm going to distribute the multiplication because I'm multiplying that A with B. If they're two-dimensional, then that means we're gonna get, let's see, 4 terms, right? So when you do the algebra, you get, so let's just write this down, AX I had plus AY J had dotted with BX I had plus BY J had, right? So what we need to do is we need to distribute this. Let's just do that. I'm gonna show how we are distributing it. So AX needs to be multiplied with 2 of those, and AY J had also needs to multiply with those as well. So what do we get? I'm gonna show what happens. So the vectors are those i's and j's, right? I'm gonna put them next to each other, and I'm gonna put the coefficients of those, like ax and bx, on the left side. Okay, so when we do ax I had dotted with bx I had, what I'm getting is ax bx. In parentheses, I'm gonna look into the vector multiplication, which is I dot I. Okay, ax bx are scalar. It's just a number, whatever they are. I can plug it in and multiply. The vector form here is I dot I. Okay, and that is not a vector because dot product is also known as scalar product. That should give me a number. Okay, so we will talk about that, but let's move on to and finish the distribution of it. Next one is I'm gonna multiply ax I had with by j had, so I'm plus ax by, those are the numbers, I dot j, right? And plus I'm gonna continue. Now I'm multiplying ay j had with bx I had. I get ay bx j had with I had. I'm using in an order, although order doesn't matter for the dot products. I want you to make a habit of that because cross product, it will matter. And we will talk about that later. And AYJ hat multiply with or dotted with BYJ hat is AY, BY are the scalar forms, and the vectors are J dotted with J, but we are going to get a scalar after that multiplication. So I dot I. So what is I dot I? Let's just look into those. Okay, so let's use the first definition. We said A dot B was AB cosine theta, right? What is I dot I? What is the magnitude of I? I is a unit vector. Why do we say unit vector? What does it mean? Because the magnitude is 1. That's why we say unit, right? And both of them has a magnitude of 1. And cosine, what is the angle between them? It is simply 0. So that is what? Cosine 0 is simply positive 1. So you're getting 1. What about I dot j? I has a magnitude of 1. J has a magnitude of 1. What is the angle between them? I is along x direction. J is along y direction. They are perpendicular to each other. What is cosine 90? It is 0. Okay, this goes away. And the same thing for j dot I. Again, magnitudes are 1, but the angle between them is cosine 90. That gives us 0. What about j dot j then? The magnitudes are 1. Angle between them is 0. Cosine 0 is 1, so the answer is going to be 1. So as you can see, only when you multiply the same unit vectors, you will get 1. Any other case, you will get 0. Okay, so this turns into, actually let's just get rid of the ones that are 0. So this term goes to 0, this term goes to 0. So the whole thing is going to go away. This goes away, this goes away. And I dot I becomes 1, j dot j becomes 1, right? So if you rewrite this, then we get ax bx multiplied by 1. We don't have anything left as i's or j's, okay? You should not see it at the end. Plus ay by. If this was a three-dimensional case, then it would be also plus az bz, okay? But in the three-dimensional form, this is the other form of the dot product that we get. So again, depending on what type of problem you're dealing with, and I usually check, do I know the vectors? Do I know the angle between them? Then I use the first form, AB cosine theta. If I am given the vectors in unit vector notation, then I'm going to use this last thing I got, and I'm going to do ax bx plus ay by plus az bz. And even sometimes we need both of them to figure out what is the angle, or maybe what is the magnitude of one of them, or something like that. So that's another practice we do. One more thing here that I want to add is about finding the angle. We had some clicker questions. Please go back to them if it is not clear. So to find the angle here, if you first write cosine theta, what do you get? It is a dot b divided by ab, right? That would mean theta is inverse cosine of this whole thing. So now assume that the vectors are given in unit vector notation. So you can also write what a dot b is, which would be like in this form if it is two-dimensional, right? This part. And a times b are the magnitudes of a and b. You can also find them if the components are given using Pythagorean theorem. And then you can find what that parentheses is, the entire parentheses, and then take the inverse cosine to find the angle. Okay, so that's another algebra that we need to get comfortable with.